title of the presentation is ALFAwetlands and Wetland Restoration for the Future, and I understood that the presentation which was asked me should concentrate more on this living lab, so my focus will be there, but of course I'm going to tell something more about that. And yes, so we can start now. And so this is the outline of my presentation. So first, something about the background, not only the living labs, and but after this, when I presented these working packages, I go to tell something about our living labs, and in the end, if there's time, something what we have achieved so far in our project and the impacts. And what is the motivation in our project? So, well, we have discussed already, or it has been told many times today, that there's this urgent need to decrease these greenhouse gas emissions. And it has mentioned today also many times that these wetlands have a remarkable capacity to sequester carbon. It is estimated that this carbon sequestration or this carbon storage of the wetlands is globally 225 billion metric tons and take about 5 to 8% of the world terrestrial landscape. So it's a huge number, cannot understand. And therefore, this wetland restoration offers a nature-based solution to reduce these greenhouse gas emissions. And we know that there are many areas in Europe and globally as well that the peatlands and wetlands, they have somehow damage. For example, in Finland, we have a lot of peatlands, but many of those have been drained. But I will tell something about those later on. And in addition, that this wetland restoration, it offers the nature-based solutions to reduce greenhouse gas emissions. Also, it has a positive impact biodiversity and other ecosystem services. And as we all know, also that the European Union has aimed to cut greenhouse gas emissions at least by 55% already by 2030, and it's coming quite soon. So we are really a hurry to cut down our greenhouse gas emissions. So, like I said before, this project is funded by Horizon Europe, and actually, this same call we have 4 different projects which are funded, and we are working together. But I'm not going to tell about those cooperation here anymore. And we started this project 2 years ago, and we will finish, or we are going to continue this until end of November 2026. So we are right now in somewhere in the middle. And we have 15 partners around Europe, from south to north, and Luke is coordinating this project. And this is our ultimate goal, which is a very challenging. Maybe we don't reach that, but anyway, the challenge, our goal is the climate change mitigation, which at the same time supports biodiversity and other ecosystem services and is socially just and rewarding. And here are the objectives which we have to reach our goal. So, for example, enhance this spatial knowledge of European wetlands and restoration, evaluate pathways of wetland restoration that incorporate the co-creation process, and enhance our understanding of how ecosystems in temperate and boreal climates respond to different wetland restoration practices and so on. And there is also this one objective to ensure the effective communication, exploitation and dissemination of the results. And this is, of course, the one reason why I'm here today. And to reach our goal, we have 5 research working packages. And in addition to that, we have this tech working package and management. And I'd like to introduce you our working packages. So first one is this meta-analysis and land use assessment for enhancing European wetland knowledge. And there we are doing mostly the mapping of the wetland, but there are also some other things what we are doing as well. For example, we are trying to use the remote sensing to do the biodiversity surveys and so on. And for example, there has been a literature survey of of the restoration, what kind of restoration has already been conducted, wetland restoration has been conducted in the European level. So there's coming a very interesting results, and I think, well, something you can find from our website, but I have to admit that we don't have a result much yet. But what comes this wetland mapping, actually that project is almost finished, and maybe during this fall we will publish this new updated wetland maps in European level. And this working package 1 is led by Alex Barthelmens from Michael Sacco Foundation in Germany. Then this working package 2, it's about the co-creation, and it's led by Erik Andersson from Stockholm University. And then we have this working package 3, and this is mostly all the ecological work what we are doing in the field. So we are doing in this under this project, for example, this greenhouse gas measurements, and we are doing this vegetation surveys and take soil samples and so on. And it's led by the Kaido Soosar from the University of Tartu. And then we have this modeling and scenarios working package, and well, there will be a different kind of scenarios relating this biodiversity, ecosystem services, and so on, and how the restoration has affected on those. And it's led by Jura Palkovic from JASA. And then we have this working package 5, which is about economic and social impacts of wetland restoration. And it's led by Emi Haltia from Luke, the same institute where I am. And there, for example, we have conducted different kind of, or we are going to conduct different kind of surveys. And first one was conducted during this summer. There was this PPGI survey where these respondents can mark, for example, the wetland areas where they are interested about, and also tell their opinion about the wetland restoration. And as all, we try to do everything in a harmonized method. So, for example, this survey, it's a similar type in all these countries, all these countries where we have where this survey is conducted. And then we have this dissemination, exploitation and communication working package, and it's led by Irina Shoka from EWS. And the working package 7, which is management, and it's led by Luke, and I'm a leader of that. And in the core of all, we have these living labs. So this is something which is very, very important in our project. And this living lab, this is well, I think this term is kind of fashion right now. But yes, we have also the living labs in our project, and there are many definitions of these living labs, and this is the one. A living lab is a research concept, iterative, open innovation ecosystem, often operating in a territorial context, integrating concurrent research and innovation processes within a public-private people partnership. And we think that in our case, this living lab is much more or less similar, like this definition, this kind of official definition is. So in ALFAwetlands, this living labs is a system where all ecological and most of the social science related work and some of the modeling are conducted. And they are in a key role in supporting and integrating interdisciplinary research on ecological, environmental, economic, and social science at the local level. So we are really dealing very different kind of things in our project. Okay, so now you can see our living lab map, and those circled sites, they compose one living lab. And we work actually in a local level, we work in a regional level and EU level. And in this living lab, we are working in a local level, and we have 9 living lab in total. And so each partner country has its own living lab, excluding Netherlands. And one of the living labs, where is the point? Okay, it's here. It's here in Austria-Hungary area. So this is the Neusiedler Sea and Ferto area, which we have talked about today already, and had a very nice presentation of that area. So in total we have 9 living labs, and we have 33 sites in our living labs, and there are 8 types of wetlands. So in our living lab, it doesn't mean that there is only one site, but there can be many. But for example, in this Austria-Hungary, there is only this one site, which is in our living lab. And for example, in Germany, this Peene Valley, it's only one site, and in Sweden as well, there is only one site. But for example, in Finland, up there, we have actually 6 sites. So it varies quite a lot. And this living labs, they are a platform for collaboration. They are a platform for upscaling the results. And of course, we cannot, because we have a different kind of wetlands, we cannot upscale these results to every place. But at least when we have, for example, peatlands in Finland, we can upscale these results. Similar type area in similar type climate conditions. And then about these wetland types. We decided in a proposal phase that we are not going to concentrate only, for example, the peatlands. We wanted that we have a different kind of wetlands. And the idea is to focus on the wetlands which are important each partner country. And in case of Finland, peatlands are the most important us. But for example, in Central Europe, there are quite many floodplains in our project. And here are the different kind of wetlands types which we have, and we have classified them by the land use. Well, this is not a very clear classification, but anyway, this is some kind of classification which we made, and we have this drained peatland forest, and we have also drained peatland which are non-productive, and we have peat extraction site and agri-peat, so they are these cultivated agriculture areas, and constructed wetlands, floodplains, coastal wetland. It's only one in Spain actually, this coastal wetland. Here, here. And we have also the managed wetland. That's the one in Sweden here. And what comes this restoration on this site? So for us, the restoration, it's not only the ecological restoration, which in case of peatland, it usually means that there will be a total rewetting and ditch blocking. So we have different kind of management methods which we are using in addition of this ecological restoration in our site, and there is also rehabilitation and revegetation actions. And the restoration status, most of the sites there has been conducted this restoration before this project started. Without that, it takes too much time if we start from the beginning. If we are going to somehow look at what is the effect of the restoration, maybe we don't get any results before this project start. So we thought that it would be good to have some historical records before we start to in our project. But we have some sites where we have conducted this restoration during our project, and one is, for example, in Finland there is a peatland forest somewhere here where we have conducted this ecological restoration. or actually it's going on this conducting. And here are different kind of management, more detail, what kind of management we have in these different kind of wetlands. So there are water level manipulation, continuous cover forestry, flood-tolerant crops, sphagnum sowing, moving fen meadow, periodic flooding, and so on. So there are multiple methods. And of course, there will be perhaps problems to upscale these results, but well, we are still optimistic that we can somehow generalize the results what we get from our sites. And this is just to remind you this general rule that this controlling the water level have effect on the greenhouse gas emissions. So it's just to simplify is to think that that when there's a high water table level, there's a low carbon dioxide and 2O emissions and high methane emissions. And when there's a low water table level, there's a high carbon dioxide and 2O emissions and low methane emissions. And when we are trying to regulate this water table level, we are somewhere between. But we think that it has a benefit to also do this restoration and have this some kind of a compromise result. And there is some photos from our Living Lab sites, but here I'm going to present some of our Living Lab, and first this Lake Nootsidel Ferdo, which we have already a very nice presentation. And here we have, here the challenge is this, which we have especially concentrate, or which we have looked at in our project, is this reed belt. And it's one of the biggest one in Europe, but there is now today problems. It cannot regenerate like it used to be before, and the moving is it's not so easy. And we know that it's a very nice place. Although there's only one plant species is growing there, there is the place for different kind of animals. So the biodiversity is quite nice. So it's good that there will be these reed belts in the future as well. But if we cannot regenerate, there will be a problem in the future. There will be a greater methane emissions, to my understanding, and so on. And this moving has been seemed to be a problematic year by year, and it's partly due to warmer winters, so the moving cannot do in the winter time. And also this fire management is nowadays it's not possible to do anymore. Okay. So well, there are some challenge restoration methods. So well, we have to somehow solve the moving problem and testing the fire management again, and there has been these channels reopening in at least in Hungary sites, and expected impacts are this greenhouse gas emission mitigation and maybe increase the biodiversity and increase in recreation possibilities and so on. This example is from the Finland, and this is the peatland forest. And in Finland, we have a 10 million hectare peatlands, and half of that is drained for forestry. And these drained peatland forests are net sink for carbon due to their trees, but their soils are carbon source, especially if they are nutrient rich. So we have these two methods how we are doing this restoration. It's a continuous cover forestry and this ecological restoration. And with this continuous cover forestry, we can regulate the water table level. So the expected impacts, they are pretty similar. Maybe the decrease of greenhouse gas emissions are less when we are using this continuous cover forestry. But there are some other positive sides. For example, this it decreases leaching of nutrients to recipient watercourses, and it has a positive effect on incomes. In Finland, for example, the forest 60% of the forest are owned by private forest owners, so it's a quite an important thing. Another example from the Spain, and there's this A case is the problem of the overgrazing. So the simple solution is to add the fences there, and there are these good impacts also found, also relating the greenhouse gas emissions. And this example is from the Latvia, where the peat extraction is especially their concern, and one solution is to practice this pericultivation, and there seem to be a lot of decrease of greenhouse gas emissions as well in practicing this pericultivation. Then this is a Belgium, and there is the floodplain, and there is a eutrophication problem, and the restoration method is infilling the ditches, raising of riverbed and acquisition of territory and moving management, and there seem to be also we expect that there will be a positive effect if we think about this greenhouse gas mitigation. So, like I said before, we are doing in this Living Lab field work, and we have also different kind of produce different kind of guidebooks, like rating this field sampling. So like I said before in the beginning, that this harmonized method are very important. Okay. Co-creation is also happening in these different Living Lab sites, and these are the lessons which we have learned so far. So maybe it would be better that all these Living Lab sites in each country, they would be concentrated in one region. It would be beneficial, and but we think that the solution that we concentrate on already existing site, it was a good solution. Because it takes time to find and set up new sites, and there is already some data available. Cooperation, we have find it's not a surprise, but it's a very beneficial, and communication, it's very important, and sometimes it's difficult to get the people in different actions and events. Maybe it's a lack of time, but also it's due that, in a lack of time, but also sometimes people are complaining that they are not included in to do the decision, so it's important to have. Okay, these are what we have achieved so far, but we can skip that, and there is the impact what we have in our project, and then I just thank you for your time.